Audio Jungle. Audio Jungle.
Here we have the rocket equation. Okay, so a rocket equation. So here I will draw the diagram and terminology whatever it is required I'll write and I will explain, but the whole derivation you will not get here. Direct result I will give, and for full derivation we will have a separate video. Okay, now so based on that, first we'll draw the diagram so that you can understand properly. Now this is what rocket. Fine. Now it is very important actually, rocket equation. The final result is very important because with the help of that only it is possible to get what is the change in velocity and all. This is what axis, horizontal and vertical axis. All right. So now our assumption is what here is that both thrust and drag are aligned. Okay, so thrust and drag are aligned. Usually thrust and drag are not aligned, but our assumption we are considering in this case thrust and drag are aligned. All right, so this is the thrust F and this is just opposite is drag. Okay, and it is making angle theta. This thrust is what making angle theta from y-axis, and this rocket is what moving in forward direction with velocity of capital V. All right. Definitely downward we will have the weight of the rocket this is the downward component, and here I can say it is mg, mass of the rocket, and g is the gravitational force. Remember, this mass will be instantaneous mass. Why I am saying instantaneous mass? Because the mass of the rocket is what continuously decreasing. Why it is happening? Because we are burning fuel, we are burning propellant, so obviously total mass will be decreasing because propellant is what continuously burning. Hope it is clear. Now now this is the exit velocity, which is nothing but VE. Okay, and the mass of the propellant is nothing, exit is nothing but mass of the propellant, or simply if I say mass m dot also is okay. Okay, done. As per Newton's second law, the motion, we know here the forces are thrust, drag basically, and gravitational weight. Okay, now whatever the mass we are having here, it is instantaneous mass. of rocket or instantaneous rocket mass. All right. So for this, we'll write the equation. If you write equation for this, so number one, you resolve the force. So what you will get? Force or mass into acceleration, which is nothing but m into dv by dt. This is mass into acceleration as per Newton's second law. Okay, what is the Newton's second law? Mass into acceleration is equal to total force F, external or total force Ft. It's not thrust, okay, total force I am saying. So mass into acceleration is nothing but dv by dt. And what is the force? Force, you check. First force is, we have a thrust force F, we can say. Then drag, if you check, it is just opposite, so drag is opposite. And check the weight component. So in the direction of motion, we are resolving in direction of motion. In direction of motion means in this direction, so mg cos theta. Why? Because this is theta, so this will also be theta. So two component you will have here. If you check, this is the one component which is mg sin theta, and this side it is mg cos theta. So minus mg cos theta. This is the first equation I have written. Second equation I will write. So directly I am writing now. Okay, as you said, direct equation you want. So better we'll write this directly. So that dv by dt value you will get. What is the dv by dt? dv by dt after solving all, dv by dt, this is nothing but pf by tv into v equivalent divided by 1 minus pf t divided by tb. Okay, minus drag d divided by m naught 1 minus pf t by tb minus g cos theta, minus g cos theta. Let me write here, minus g cos theta. Okay, so separately I will write here equation 2 better. dv by dt, we will have pf tb effective exhaust velocity divided by 1 minus pf t by tb minus drag m naught pf t by tb minus g cos theta. This is the equation. Okay, this is called rocket equation, or this is called rocket equation. Rocket equation. All right, now this one is called drag loss due to drag in acceleration, because dv by dt is what? Acceleration. So there will be loss in acceleration due to drag, and obviously drag is nothing but opposition, or it is against the motion force. Okay, it is the loss basically, and this one is the gravity loss. Why it is called gravity loss? Because small g term you are getting, and a small g, which is the gravitational acceleration, and this acceleration obviously it is vector quantity. So what is the direction of gravitational acceleration? It is always downward. So once rocket is moving in upward direction, so gravitational acceleration will be working in downward, hence it is called gravity loss. Okay, all right. So the same thing I have written, the second equation. So this diagram, first you need to understand neat and clean. It is moving in a forward direction, upward forward direction. Okay, upward forward direction. So definitely whatever the force you have resolved, F minus D minus mg cos theta, it is along the direction of the motion of rocket, along the direction of the motion of rocket. So and as per Newton's second law, you know, as per Newton's second law, as per Newton's second law, what is that? Mass into acceleration is force, or force is equal to mass into acceleration. So mass into acceleration you can write dv by dt, and is equal to external forces. So it is F minus D minus mg cos theta. All right. Now, so like all the term you have seen, this is called drag loss, this is called gravity loss, and it is very important. Okay, and now what is the important, the terminology, because I have skipped the derivation, so I need to write what is PF, what is TB, what is T. So please check here, this small t is nothing but instantaneous time. TV, it is total burning time. Total burning time. Okay, and it is effective exhaust velocity. Somewhere you may get here, it is PF, right? PF, it is called propellant fraction. Propellant mass fraction. So this PF, in my previous lecture you have seen it was zeta. It is nothing but mass of the propellant divided by initial mass m naught. Okay, so this is the component. Now this is called rocket equation. This is called rocket equation. Okay, this is called rocket equation. Fine. Now this is the actual equation, but we have two different cases. What are two different cases? In first case you will say neglecting drag loss. Okay, second we can say neglecting gravity loss. So in both cases we'll have a different equation. Here I'm just going to write the final result. Okay, and okay, so we have to consider case 1, which is nothing but so this case 1 is neglecting or negligible drag loss. Okay, so we can consider, okay, d is approximate to 0. So the second term, see in this case, this is the first term, this is the second term, and this is the third term. So in the second term d will be 0. So what will be the result you have? Here the result is d by dt now EF TB B equivalent divided by 1 minus PF T by TB minus G cos theta. Okay, so here few steps you have to continue, and once you derive, okay, this full derivation, as per gate requirement derivation is not required. So once you integrate this above equation here over a period of time equal to burning time TB to get the incremental change in rocket velocity, okay, and that change in rocket velocity, and what will be the limit you have to take, we need to write when t is equal to 0, velocity v is equal to v naught, okay, and when t is equal to tb, then velocity v is equal to vb. This is the limit you have to integrate. Integrating equation 4. So if you do that, then final result you will get here, and this final result is nothing but delta v, which is nothing but vb minus v naught. Okay, it is vb minus v naught. You will have minus v equivalent ln 1 minus pf minus G cos TB. TB is the burning. Okay. All right. Now this is what, fine. So after few steps, I mean after integrating and putting the limit, so you will get this. So here you are getting 1 upon 1 minus PF. This one need to understand how you can manipulate this. So 1 minus PF. What is the PF? It is propellant fraction. I told you here, and it is nothing but MP by M naught. Check. It is MP by M naught. If you solve this, then what you will get? M naught. So this is what initial mass M naught, and this M naught minus MP, in previous class I explained, this is called also MF. MF is nothing but final. Final means mass of the system after operation, mass of the rocket after operation. Before operation M naught, after operation MF. So after operation means MP will be reduced. Why? Because propellant has been burned. Okay. So this is M naught. Also sometimes in few books you may get MF, you may get MB. MB is called a burnout mass of the vehicle after all the propellant is consumed. Okay. So, and this M naught by MF, it is also called, you can have this value M naught by MF. Okay. So this value you can write, this is what M naught, and here this is obviously MF. So again I am just writing 1 upon 1 minus PF. You can write M naught by MF, and this also you can write 1 upon MF by M naught. If you remember, this was mass ratio. It is called mass ratio. So 1 by MR. So 1 upon 1 minus PF is nothing but 1 upon MR. Okay. So 1 upon 1 minus PF also you can write 1 upon MR. MR is the mass ratio. In my last lecture I had explained it is nothing but final by initial. Final means after burning. NB, as I told you, NB in few books use NB means burnout mass after the rocket, burnout mass of the vehicle after all the propellant is consumed, MB. Okay, and MR is the mass ratio of the vehicle. Okay, so now this delta V, I can say delta V is nothing but it is V equivalent ln 1 by MR, 1 by MR. Okay, and 1 by MR minus G cos TB. TB is the burning time. So the same equation we can write in terms of specific impulse. What is the V equivalent in terms of specific impulse? It is nothing but, if you remember, it is ISP G ln 1 by MR G cos TB. So finally you have equation which is nothing but VB minus V naught delta V is equal to V equivalent ln 1 by MR minus G cos TB is equal to ISPG ln 1 by MR minus G cos TB. This is the master equation. Okay, based on this question they are asking in exam. So that derivation I have skipped. In between I have skipped the steps which was not required, but for the full derivation if you want, then separate video will have. Okay, separate lecture we will have that time. All right, so this is called the final equation or rocket equation, and this delta V is called change in velocity. What it is called? Change in velocity. So, or sometimes it is called increment change in rocket velocity. Increment change in rocket velocity. What is the delta V? Incremental velocity, or R, it is called change in rocket velocity. In incremental velocity, or sometimes incremental velocity of rocket, or sometimes it is called change in rocket velocity. All right. So this is the final formula. Second one, we have the another case which is called case 2. So here we have a G cos TB. TB is the burning time of the propellant, and G cos theta. Sorry, this is G cos theta. I forget. I made this as a angle here. Here also I did same. No. Here G cos theta. Na? Check G cos theta. Please correct this. So this is nothing but G cos theta. Okay. G cos theta. TB is separate. Don't consider it is as an angle. No, it is G cos theta. My mistake. Correct this. Here also. Please correct this. It should be a cos theta. No? Because TB is the burning time, not theta. G cos theta. All right. Now, another consideration we can have, and this consideration called case 2, and this case 2 is what we are considering. We do not have gravity loss. So we will say neglect gravity loss. So in this case, G will be 0, okay, and G will be 0 in the sense what? That G cos theta, this term we can consider as 0, because if you say G 0, then there will be confusion, okay. So this G cos theta, okay, this part is approximate to 0, you can say. All right. So because if you are saying gravitational force almost 0, that means it is called gravity free flight, or you have to assume that time that vehicle is what traveling in space. Yes or no? Vehicle is what traveling in space. That's the mean of it. And when it is possible, when it is that rocket is what flying in horizontal flight condition. So if you take horizontal flight condition, so what will be the theta? I can write here horizontal flight. Theta will be 0. So here in this case we can write del V is equal to V equivalent ln 1 upon mr minus G cos 0 into TB. So this is nothing but V equivalent ln GTB, and this also V equivalent you can write ISP G ln minus G TB. So you can write ISP ln 1 by mr minus TB, and this is nothing but G. Now here so this is also theta. Please correct. Fine. So finally this is the equation, but you are considering that neglecting gravitational force, because you are saying if the vehicle is traveling in space, then the change in velocity due to gravitational force will be almost zero, which is called gravity free flight. So that you can consider here. If the vehicle is traveling in space, then the change in velocity change in velocity due to gravitational force will be almost zero, which is called gravity free flight. This word should remember, okay? Gravity free flight. So what is the mean of gravity free flight? If you are getting there is no change in velocity of the rocket due to gravitational force, then that type of flight operation called as gravity free flight. Hope it is clear to you. Now, so finally, you are considering the gravitational force also zero, so you have delta V now only V effective velocity ln 1 by mr, okay, and this also you can write in terms of specific impulse, which is nothing but ln 1 by mr, right? This is the final, and the all question whatever it is asked in your gate related to rocket equation or any exam, one day exam, HL or any DRDO exam, rocket based question they are asking based on this formula, okay? It is very important. And this equation also known as Tsiolkovsky rocket equation. Tsiolkovsky rocket equation, okay? Let me write here. This is also known as T silent Tsiolkovsky V rocket equation. So finally you got the final equation. Actually, if you derive this, so it is very easy only, but it's time consuming, that's all. Done. So done. Now here, based on this we have some formulation, and you will get burning time. Sometimes they will ask like, okay, what time propellant will take to burn completely, so it is called burning timing, TB. Sometimes they ask calculate that value, so how to get that, okay, how to get that. So with the help of this equation only you can calculate here, okay, finally. And this is what change in velocity, okay, change in rocket velocity. All right. Now we need to find burning time. How to get the burning time here? So How to calculate that? You know this formula we have used, and it is nothing but we have delta V is equal to burning velocity minus initial, which is nothing but V equivalent ln 1 by mr is equal to ISP G ln and 1 upon mr, and mr is nothing but final by initial, so I can write initial by final, means m naught by mf. This is also okay. So if you check what is ln m naught by mf, in short I am just writing it is delta V divided by ISPG, okay, or you can say delta V by V equivalent. So if you calculate m naught by mf, so it is nothing but exponent of delta V by V equivalent. So this m naught also very important. Sometimes this final and this value they will give to you, and you need to calculate this m naught. One time I think the question they had asked. So please remember this formula also. That's the reason I am giving this. So m naught initial mass and this is the final mass, or it is also called burnout mass. Sometimes they will use term burnout mass, so please remember, okay, mf also called burnout mass. Now so this m naught is what you have m naught, this m naught is equal to, you have mf e to power delta V by V equivalent. What is the mf final mass? It is initial mass minus whatever the amount of propellant mass consumed, it is reduced, so m naught minus mp e to power delta V by V equivalent. M naught is equal to, we can write m naught minus, this mp is the propellant mass, but this we can write mp dot. If you want to write, you can write mp dot. So if you write mp dot, then definitely this will be burning time, okay, because mp dot means what, mp divided by t and multiplied by tb, so that t cancel out, so again mp you will get. So this is the bracket e to power delta p by v. Now this tb you can calculate, you do some mathematics, tb you will get, what value you will get, it is m naught by mp, okay, in bracket 1 minus 1 upon e del v by v equivalent, okay. So remember this formula, this is called burning time of the propellant. All right, done. So now we are moving ahead, and we are having next article, which is called payload ratio or payload fractions. Similarly, we will have a structural weight ratio, or sometimes also called a structural fraction, okay. And so these terminology why I am giving, because if you check previous year gate questions, even not only gate question, as I told you, any one day exam, HL or DRDO or SHEP, ISRO separate exam they are conducting. So if you check in rocket propulsion, rocket problems, they are using this fraction values. So if you know the fraction values meaning of it, then you will able to solve the problem. Otherwise, that term will come, and if you don't know, then it is difficult to solve the problem. So this is the one-liner theory only, but at the same time, with the theory, I will give the formula also. Okay. So because I'm trying my best to avoid theory part here, because it's totally numerical subject, only numerical they are asking, they are not asking theory, but here it is formula with theory I'm giving, okay. So one liner theory only you have to remember. So first term we are having payload ratio, okay. This is called payload ratio. Payload ratio. So before going to this, you need to remember here we have a rocket. And obviously you can consider it is as a multi-staging, it's your choice, but only terminology, whatever the terminology we have here, I'm just going to explain that. So okay, so here we have a payload, and this payload mass is what denoted by ml. Already I have given this terminology, but again I am explaining. This is what propellant, and it is mp. This is the structural mass, and it is denoted by ms. Okay, this is the propellant mass, and this is the payload mass, propellant mass. Okay, so based on this, we have a payload ratio, or it is called, or it is called payload fraction. Okay, remember it. So what is this? This is nothing but ratio of payload mass to initial mass. Initial mass of rocket. System. It is denoted by lambda, and the whole rocket system we have, it is called initial mass, and it is denoted by m naught. Okay. Finally, so what we have a lambda. Lambda is nothing but ratio of payload mass. What is payload mass? It is ml divided by initial mass. What is the initial mass? It is m naught. Or it's your choice if you want to write small ml by ms, because your practice is what small f like mp and mass of propellant and all you have practiced. So you can write ml by m naught, no problem. Okay. And what is the m naught? It is initial mass. What is the initial mass? Start from payload. ml plus mp plus, for only one stage I am talking. If it is second stage and third stage, then calculation will be different. So this is what the payload fraction. Always remember now one word, it is denoted by lambda, and it is nothing but mass of the payload divided by mass of initial mass of the rocket system. It is called payload fraction. Always remember, it is called payload fraction. And payload mass, it can be anything. It can be satellite, it can be space probe if it is the space mission, or if it is a space mission also it is astronaut, right? So payload in the sense maybe astronaut or space probe or satellites, whatever you are keeping here for the mission, it is called payload. All right. So if suppose problem came and they have given 4 astronauts are inside, then that mass definitely they will give to you for the calculation. So you have to consider that number of astronauts into mass for each given, so you can calculate mass of the payload in that way. If suppose problems came in that way, okay. All right. Next is what? Next theoretical part we have. It is called structural weight ratio. Structural weight ratio, or it is also called structural fraction. Okay. So diagram I already have given, so from there we can write the equation. So it is defined as ratio of structural mass to initial mass of rocket system. It is denoted by delta. It is denoted by delta. All right. So, sir, what is the delta now? So, delta is mass of the structure ms divided by initial mass m naught, or you can write in small ms divided by m naught. It is ms divided by what is m naught? You have starting mass of the payload, mass of the propellant, mass of the structure. So this formula you need to remember. Delta is equal to ms divided by ml plus mp plus ms, and this is nothing but ms divided by m naught. Okay. So whatever the articles I am giving here 1, 2, 3, it is for the numerical purpose. Okay. If you remember this, then once numerical, because in numerical they will say simply, they will say the structural fraction value is 0.6 or structural weight ratio values is 0.3, something they will give to you. So if say weight, so weight, structural weight divided by initial weight, I am writing in terms of mass. If they are talking about weight, then multiply by g, and obviously in numerator and denominator it will be cancelled out, so nothing to worry. Nothing to worry. All right. And what here I have discussed, this is for the single stage. Sorry, if it is for multiple stage, so the method will be same, but the way of calculation for each stage, that value calculation will be different. Okay, so that time we will solve one numerical for multi-stage rocket system. For 3, 4, 5 stage, one numerical will solve and it will be clear. Okay. All right. Now another very important part here, we have to derive the relation between this. Why? Because the fraction they are giving us, they will say, okay, mass propellant fraction is this, structural fraction is this, payload fraction is this, and the whole sum will be 1. We should know that. Otherwise, for two fraction they will give the value, and third we should know how to calculate. For that reason, we need to get the relation between all three. How to get this? Very simple. So now we have a third, we can say, the relation among zeta, delta and lambda and delta, sorry, lambda and delta. What is this zeta? It is, zeta is nothing but propellant fraction. Propellant fraction. It is payload fraction. It is structural fraction. How to get this result? Check. What is the initial mass? Of rocket system? It is m0, sorry. Check the diagram, previous diagram, it is m0. For this rocket system, check how to calculate the mass. It is mass of the payload, mass of the propellant plus mass of the structure. So we can write mass of the payload ml, mass of the propellant, mass of the structure. Both sides you divide by m0. So these small tricks are very helpful in your numerical, okay? For numerical purpose I am doing. I know you are not going to write this definition for your exam, but yes, for numerical purpose it is very important. So m0 by m0, ml by m0, mp by m0 plus ms by m0. m0 by m0 is 1. ml by m0, it is payload fraction. It is denoted by lambda. Plus mp by m0, it is the propellant, right? Propellant fraction. It is denoted by zeta. ms by m0, it is the structural fraction denoted by delta. This is lambda, this is delta. Okay. Now you have result this, and one more thing we need to write this. If I say PF, propellant fraction, so it is nothing but zeta. Yes or no? And this zeta you can write in terms of 1 minus, take this side, zeta, 1 minus zeta, then what you will have? Lambda plus delta. And this 1 minus zeta, if you check, it is also mass ratio. Check here and listen carefully and use this, okay, carefully, because each and every terms is what pointing towards your exam, because sometimes it is used in your exam. For that reason I am giving each and every steps here. So don't think one step I am giving a useless purpose. No, every steps are here useful. So listen carefully and use it for your exam, okay? So check 1 minus, somewhere here it is written here. So This one, check, this is what, 1 minus pf is equal to, you got finally here what you got, 1 minus pf. I told you pf means zeta and this is nothing but mr. Here it is proved, so no need to prove again, directly you can write. Okay, so finally you got this result, and which is very important. Okay, very very important. So 1 minus zeta is equal to mr, and this is also lambda plus delta. So you will see the magic of this. Why? Because for multi-staging it is very useful. This is very important. Okay, all right. Now if you check the value of the change in velocity in terms of this, what terminology till now you have learned in this format, if you want to write your change in velocity, then how to write this? So see what we have, change in velocity, again I will write change in velocity of rocket. As I told you, this is also called incremental velocity of rocket. Okay, sometimes they will use this term also, so I have written. So now delta v, if you write in final touch, so you can say it is delta v, what you have, it is v equivalent ln by mr. So this you can write v equivalent ln by ln of 1 by mr, no? That formula you had seen already, I am not going back again because you have written somewhere or you know this. What is 1 by mr? Check here, what is 1 by mr? So from here I can say 1 by mr is nothing but 1 by lambda plus delta, or here also you can see 1 by mr is 1 upon 1 minus zeta, no? So this one you can write 1 by mr is nothing but you can write um, it is lambda plus delta. So they will give value in terms of this also, they will say directly, they will give lambda and delta. So if you know this formula, directly keep this value lambda and delta, direct you can keep and you can get change in velocity. Okay, v equivalent of ln 1 minus zeta also, no? See this 1 by mr is 1 by 1 upon 1 minus zeta. So this is the formula, or yes, somewhere you may get this formula in terms of ISPG also, so the same thing you will have. Please write this and remember this formula. Okay, this formula should be on your tip, because question they are asking directly, question they will ask based on this formula. All right. One more thing I'm missing, I should add here only. They have used one time called structural coefficient. This term also you need to know. Okay, especially this is the structural coefficient. What it is called? Structural coefficient, and it is denoted by epsilon. It is denoted by epsilon. What it is? This is also very important parameter. It is the ratio ratio of ratio of structural mass structural mass to the sum of structural and propellant mass. Okay, so this is the combined joint venture. Okay, and if you join two things, structural mass and propellant mass, so that ratio if you get, then new terminology called structural coefficient. So sometimes they will use this also, and it is denoted by epsilon. It is denoted by epsilon. So what they said, it is the ratio of structural mass. What is the structural mass? Ms divided by structural sum of structural mass plus propellant mass. Okay, so this also you need to remember, and this formula is what you have to exchange this and check what result you will get. Okay, what you have now, this is the one more article, you need to remember this. Okay, so what you have, initial mass is nothing but mass of the payload plus mass of the propellant plus mass of the structure. So from here, what is the ms plus mp? Ms plus mp is nothing but m naught minus ml. Okay, so I can write this epsilon, which is nothing but ms divided by ms plus mp, and this structural mass also you can write m naught minus ms plus mp will be m naught minus ml, right? And what is the ms? Ms will be m naught minus ml minus mp. So m naught minus mp will be mf. Okay, I will show one more substitution here, or here only you can understand. See, so what is the, because ms you want to write, so what is the ms? Check from here only. Ms is nothing but m naught minus mp minus ml. What is m naught minus mp? I have told you this m naught minus mp is also called mf. If you check somewhere, m naught minus mp, mp means after burning of the propellant. So m naught minus mp, check somewhere it is written in last lecture. I think I had written m naught minus, here check m naught minus mp. M naught minus mp is nothing but mf, no? Final mass, or sometimes called burnout mass. mb also, it is called burnout mass. It is mb is also called burnout mass. I told you it is used, this term is used in exam. Okay, burnout mass. So burnout mass or mf is same. So what is mf? M naught minus mp. So check here, m naught minus mp also you can write mf here. m naught minus mp is also mf. mf minus ml. Now it is fine. So ms plus mp is m naught minus ml, okay, and ms is nothing but mf minus ml. Now I can write directly. So what is ms? Ms is nothing but mf minus, what is ms? mf minus ml divided by, what is ms plus mp? Ms plus mp is m naught minus ml. This substitution is very, very important. Okay, need to remember this. Need to remember this. Okay. Check again. We'll write 1 by mr. So what is 1 by mr? It is 1 upon mr is nothing but f m final by m initial, if you remember, or also you can write m naught by ml. What is the m naught? Just now you have calculated. M naught is nothing but, check, what is the m naught? It is ml plus mp plus ms. Okay, now and m naught by mf you can write m naught divided by m naught minus mp. If you solve this, then you will get, we use previous relation, it is 1 plus lambda divided by epsilon. What is the epsilon? That structural coefficient, epsilon plus lambda. So one more formula you got, 1 by mr is equal to this. So now if I write delta V finally, so what is delta P? Delta V, it is V equivalent ln 1 by mr. So this also you can write V equivalent ln 1 by mr is nothing but 1 plus lambda divided by epsilon plus lambda. This is also the formula. Okay, this is also the formula. If they have given suppose value in this term, so you can use this formula. If they have given this, that is structural coefficients and all, they have given in this format, then use this formula also. Okay, and rest, you know, it is the epsilon plus lambda plus delta, all format you have written. So in single formula better I will write this. This is okay. So guys, this is the final. Okay, now I do not have a single formula for this. This is the final what I have related to the rocket system. All the formula here I have given to you. Now it's your choice how to use this formula. How to use and where to you have to use this formula. It's your choice. You need to check the problem. Whatever they have asked, based on that, use this formula. Okay. रॉकेट का यही ब्रह्मास्त्र है ना। अब आपको ब्रह्मास्त्र मिल रहा है, उसके बाद जैसा मर्जी वैसे यूज करो। ठीक है, डन।